dy dx plus 2y equals xy cubed. So let v equal y to the 1 minus n. It's a Bernoulli's equation. Everything's arranged in the correct position, so the value of n is 3 here. So it's 1 minus 3, which is y to the minus 2, which is 1 over y squared. So here, let's get dv dy then, is equal to, it's a function of a function, so it's minus 2 y to the minus 3, power rule, multiplied by the something, which is y, dx. So you get that, which equals minus 2 over y cubed, dy dx. So that tells us then that dy dx is equal to, the minus can come over, the y cubed comes up, the 2 comes down, doesn't it? And then we've got dv dy here. So substitution now gives, so subs gives, now we had dy dx to start with, so I'll just write that down straight away before we move up and have a little look at the other terms. So there's dy dx. Then what have we got? Plus 2y equals xy cubed. So plus 2y is equal to xy cubed. Divide by y cubed then. Well, I'm going to multiply by minus 2 over y cubed. And that would change that to 1, won't it? Gives dv dy minus 4 over y squared, isn't it? Because one of the y's will cancel. The 2 times minus 2 will give minus 4. Y over y cubed will be 1 over y squared, and we can replace that with a v. Times this by minus 2, the minus 2 goes there, and the y cubed goes, doesn't it? We're just left with x, because the y cubed on top, y cubed underneath cancels. So we've got our integrating factor first order differential equation now. So here, the integrating factor, is all arranged in the correct order, isn't it? Is e to the integral p. So let's circle p then, so we're all happy with that. This is the number of v's, isn't it, in this arrangement here. So let's do that then. It's minus 4 dx, which is equal to e to the minus 4x. So that's the integrating factor. Multiply through by the integrating factor gives. Let's see what we've got then. So we're going to multiply this equation then through by the integrating factor, e to the minus 4x dv dx minus 4, put it in the middle here, e to the minus 4x times v equals minus 2x e to the minus 4x. There we go. Now circle the u and the v, because that's the method that we use, isn't it? An integrating factor method. This is the u component, this is v, and the derivative of the product. So we can now just write down d by dx of u times v. E to the minus 4x times v is equal to minus 2x e to the minus 4x. Integrating them, both sides with respect to x. So integrating now gives, so the integral of the derivative is just what's inside, e to the minus 4x times v equals, the minus 2 can come out the front, and we've just simply got the integral of x e to the minus 4x, and that's a product, so we need to use integration by parts. So let's draw our grid and do that quite straightforwardly. So here v is x and du is e to the minus 4x, so dv will be 1, and du, this is a function of a function, so it's e to the minus 4x, and we need the minus 4 underneath, don't we? So there's all our constituent parts for the integration by parts to be done. So let's have a go at that. So what have we got then? We've got e to the minus 4x times v is equal to minus 2 lots of brace. uv is the first product, which is this times this. So we've got minus 4x. See, the minus can come with the x. Oh, over 4, sorry. So it's minus x e to the minus 4x. So I've put the minus up the top and the 4's underneath. So there's u dv minus the integral of u dv dx, isn't it? Which is a minus, so that makes that a plus, e to the minus 4x over the 4, because I've already put the minus there, haven't I? Dx. Okay, good. So close brace then. Don't forget we're timesing it all by minus 2 there, aren't we? So we've put that at the top. So what have we got then? E to the minus 4x times v equals. Now let's expand the bracket as well as do the integration. So this is 2x e to the minus 4x over 4. Right, and this one is going to be a minus. And I'm going to take that 4 outside the integral with the 2, and it's going to be minus a half. And now I'm going to do the integration, and it's simply the integration of this, which is e to the minus 4x over minus 4. So that makes that a plus, and then plus a k at the end, isn't it? So what does that give then? So let's multiply through all the way through by e to the minus 4x, and replace v by y over x. Y to the 1 minus n v is, which is minus 2. So I'm going to write that as 1 over y squared. So 1 over y squared equals, now I'm timesing all the way through by e to the 4x, so we'll just get an e to the 4x come up here, and all these will be 1s, won't they? So the v is 1 over y squared, this is a half, so it's x e to the minus, which I'm timesing by, x over 2, plus 1/8, plus, remember we said k e to the 4x was there, because we times it by e to the 4x. So let's just double check that. V is 1 over y squared. We've times everything by e to the 4x, so that's why that's there. And that's why all these are 1s. V is 1 over y squared. This is x over 2. This term here is 1/8 with a plus. And this is a k. Good.